Welcome to Spark STEM Scholars.
Today, we'll talk about rates on SAT. Usually, they're pretty straightforward, but for the ones that aren't, I recommend using conversion factors or dimensional analysis to find the solutions. First, let's start off with something simple and intuitive. Let's say a rocket has 360 gallons of fuels after 2 hours of flight. After 6 hours of flight, 100 gallons are left. It burns N gallons of fuels for every hour of flight, where N is constant. What is N? So here we can figure out the rate pretty intuitively. We have 6 minus 2, so we've traveled 4 hours total, and the rocket burns 360 minus 100 as 260 gallons. So you divide 260 by 4 and you will get 65 gallons of fuel every hour. So that's a pretty simple problem. Let's take a look at another one. A box at a supermarket can hold 6 oranges each. Each orange costs 20 cents. Given that the supermarket has a budget of $540 to stock oranges, how many boxes will the supermarket be able to fill? So let's do this in the intuitive way and also dimensional analysis. So if each orange is 20 cents, then $1 would be enough for 5 orange. And since we have $540 as a budget, then that would be enough for 2,700 oranges. So we can buy this much oranges. And if you divide that by 6, 2,700 divided by 6, you get 450 boxes. So that is it's still a pretty simple problem, but let's do this in conversion factor way. So usually we take the given value. So it is given that we have $540. And to cancel this out, then we would multiply by, so the unit of the denominator will also be dollars so that it can cancel out with that. So $1 will be 100 cents. That's a non-unit conversion. And to cancel, and set, our ultimate goal is to get the unit of boxes. So we also know that 20 cents is worth 1 orange. So we have 20 cents and 1 orange. And 6 oranges equals to a box. So 6 oranges and 1 box. And we can also the units cancels out numerator and denominator. Now all you have to do is 540 times 100, divide everything by 20 times 6. And that will give you the answer of 450 boxes. So it's also a pretty straightforward way to do it. So let's try another problem using this method. A car can travel 1 mile in 1 minute and 15 seconds. At this rate, how many miles can the car travel in 2 hours? The question asked how many miles in 2 hours. So that would be our starting factor. And ultimately, we want to end up with something miles. So let's write 2 hours. And let's get the hours in the denominator. And we know that 1 hour is equal to 60 minutes. So get the minutes on the bottom. And 1 minute is equal to 60 seconds. And we also know that 1 minute and 15 seconds, that is 75 seconds. We know that the car can travel 1 mile in 75 seconds. So 75 seconds is equal to 1 mile in this problem. And that will get us to 60 times 60 over 75. And our answer is 48 miles. Hours cancel, minutes cancel, seconds cancel, we're left with miles. All in all, the units should cancel as you go along. If the units are canceling, then you are doing the right thing. So let's take a look at this problem. Pause the video and see if you can do it. So a train travels 32 kilometers in 14.5 minutes. If it continues to travel at the same rate, how many kilometers will it travel in 2 hours? So once again, 2 hours is our given, and our goal is to get kilometers. So 2 hours times, we know that 1 hour is 60 minutes, and 1 minute, actually, we don't need seconds this time since the minute is given. So we know that 14.5 minutes, the train can travel 32 kilometers. So it will be 2 times 60 times 32 all over 14.5. And that will be, then we will get around 264.8 kilometers. That wasn't too hard, was it?
Great job today. Keep practicing and you will be ready in no time. If you found this helpful, like, subscribe, and share with a friend who needs math help. See you next time.